Thank you. Good morning to all of you. In behalf of Dr. Dean Velasco, Dr. Maria Luisa Velasco of the College of Development Communication, as well as Dr. Pamela Studio, I'd like to thank the Third World Study Center for having us here. Our experience in natural disaster reporting in the Philippines tells us that at least three actors are always in the limelight whenever a massive disaster strikes. The scientists who are believed to have failed to laymanize science concepts that could have saved the victims, the public who are believed to have failed to act because of their cluelessness about the nature and implication of the disaster, and the media who report that human interest conflict. When the immediate effects of the disaster wane, fault-finding and finger-pointing of whom to blame usually signals the start of a collective reflection leading to recovery. Unfortunately, this recovery phase is shrouded by discourses of attribution, censure, and criticism among the scientists, the public, including policymakers, and the media itself. Recent disasters such as typhoons Ondoy, Pepeng, Sendong, and Yolanda had taught us the importance of collective self-reflection that have led to the explicit acknowledgement of each other's limitations. Scientists started to seriously question their efforts in communicating risks to the public. The public started to critically look for meaningful information about risks from the media, and the media started to challenge themselves to go an extra mile by redefining their professional responsibilities with scientists and the public as their experts and partners. But among these three actors, the mass media has become more affected by this reflection of the content, processes, and objectives of local and national disaster risk communication. This is so because majority of the Filipinos rely in media for disaster and risk information. In a survey conducted by the Social Weather Station and the Asia Foundation in 2014, a month after Yolanda, 92% of the Filipinos said that TV was their primary source of Typhoon Yolanda warnings, followed by radio with 48%. Through these figures, it is easy to understand why all eyes are now on the media, as they are expected to mediate between scientists and the public by communicating the science of natural disasters with their corresponding risks effectively and efficiently. As we evaluate the local disaster reporting in mass media, it is good to answer some fundamental questions to situate our discussion. From where does the idea of communicating science and risks come from? Why does science usually get bad publicity? And why are the media receiving blame for public's ignorance? What is the role of mass media in communicating science and risks? And what is the future of science reporting in the Philippines? This public lecture aims to answer those questions. First, we will trace the history of the gap, either perceived or real, between science and the public, to argue that the need for science and risk communication was born out from that dichotomy. Second, we will put the two different cultures, science and the news, in a dialogue to point out where the challenges of communicating science in the media reside and show the implications of such disconnection. Then, we will discuss science communication and risk communication to identify the media's potential role in communicating risks. And lastly, we will explore the challenges for both the scientists and the media to consider if we are serious in our efforts in communicating risk and not risking miscommunication. The whole idea of communicating science principles, where risk communication is also a part of, can be historically rooted from the time when the dichotomy between science experts and the masses was brought to the fore. This is somewhat expected, as communicating science and risk involves two different primary actors. The scientists, where the topics to communicate came from, and the public whom they wanted to educate. In this classic linear perspective, science communication was legitimized. Literatures in the history of science show that the scientist-public dichotomy did not exist up until the 19th century. Back then, scientists openly engaged in the so-called public, at least to those who belong to upper social stratum. The dichotomy only arose in the late 1800s when science was professionalized as an implication of the scientists forming scientific institutions and organizations, such as Royal Society of London. This has resulted to the classification of expert scientists who produce knowledge and the non-scientist publics who are not professionally included in this elite group. This social exclusion was further highlighted during the industrial era when increased commercialization started to treat the public as passive consumers. Science as a means to creating knowledge then had become a sole proprietary of the learned and the academic. Creating the producer-consumer dichotomy has led commercial printers to popularize science in the form of science magazines and later in other media, legitimizing the need for science writers and reporters. Science was presented as practical, enjoyable, and entertaining, and several popular magazines discuss science topics that are mostly applied in nature, such as agriculture and health. Later on, science had become so entangled with popular culture, the need to distinguish between technical science and popular science became a necessity, at least from the point of view of the scientists. The dichotomy between theoretical, genuine scientific knowledge by scientists and the opinionated, often trivial scientific beliefs by the public might have delineated the roles and functions of the two actors, leaving the communication aspect of these concepts and its translation to practical terms to no one. This later on became the task of science communicators, the third actor who is usually portrayed as someone who bridges the gap between scientists and the public. The history of science communication in the Philippines is yet to be explicitly written, as well as the local methods on how science can be effectively communicated. But hints about its early attempts can be found in the local history of science. As in the other colonized countries, early science communication efforts started from geographical and local social behavior reports, descriptions of existing flora and fauna, and materia medica, most of which are published for foreign consumption. During the Spanish colonization, the creation of Sociedad Económica de Amigos del País paved the way to communicate agricultural concepts and practices through the use of both technical media, such as the Boletín de la Real Sociedad Económica de Amigos del País, and popular media, such as circulars and pamphlets. Interestingly, it can also be surmised that popularization of science topics was done in some community newspapers like what you can see there. El Ilocano published in June 28, 1889, with Isabel de los Reyes as publisher, discussing in Ilocano the information about how the planet Earth came about. This section had discussed the roots and rationale of communicating science by pointing out that the need for such existed simultaneously with the realization of scientist-public dichotomy. It was implicitly discussed in the literatures that the scientists themselves maneuvered the existence of that dichotomy to keep their social prestige. The dichotomy brought a gap which legitimized the existence of science communicators, and science communication was already evident in the pre-American period. But to explain how the media situates itself as an active player in science communication, it is imperative to discuss first the complicated relationship between science and communication, particularly the media. The next section addresses this concern. Science communication scholarship has been dominated by studies that investigate the relationship, especially the tension between science and the media. The archetypal argument is that the humanistic depiction in the media of an objectivist enterprise such as science breeds misrepresentations and information distortions, which obviously are hostile to science and does not help in cultivating science literacy among the various publics. Everybody's assumption that risk messages should come from the media as part of their social responsibility to communicate relevant information in times of need had led scientists and the public and everyone in between, sometimes including the journalists themselves, to blame media for public's ignorance. Two general arguments were commonly used in the literatures to explain the existence of such tension. One is rooted from the argument that science and the arts have stark and incompatible differences. The debate dates back to the Renaissance period but had been popularized by C.P. Snow in 1959. The other one comes from the assumption that scientists and media practitioners have different, usually conflicting professional values that are rooted from the very nature of positivistic science and the newsroom culture. The lack of proper venue where scientists become acquainted with media culture and media practitioners become acquainted with scientific culture has reinforced this tension in the expense of the public being misinformed. Several literatures had already pointed out the professional disconnect between scientists and media practitioners, particularly the journalists. The sources of these tensions include the following. Journalists perceive inaccuracy of scientific news reports. Issues on accuracy are important for both scientists and journalists, but as Dunwoody argued, they use different criteria for evaluating accuracy. Scientists focus on details, thus omissions in news articles such as the researcher's methodology were judged as inaccurate. On the other hand, journalists argue that many details may not be included anymore, as these are written for the public and not for their scientist colleagues. Terms and metaphors being used to explain a scientific concept, such as a certain risk, with an aim to simplify and laymanize, is also a common and recurring issue. This had been seen on the debate of the use of terms between storm surge and tsunami, where non-scientists argue that using the term tsunami to mean storm surge would have had saved lives of many due to the meanings the people attached to it. Of course, the scientists thought otherwise, since risking miscommunication by using an inaccurate metaphor is a grave mistake in science and is believed to lead to another, probably more serious semantic problems later on. Negative stereotypes of one towards another is another. Scientists may see journalists as incompetent in understanding complex science issues, resulting to sensationalized and inaccurate science news, while journalists may view scientists as incompetent in laymanizing complex science concepts that are viewed as impractical and impersonal. Scientists are also reluctant, or at least very careful, in divulging scientific information with the fear of preempting the release of such information that are yet to be published in scholarly journals. Objectivity in reporting. Scientists are trained to work objectively, but journalists acknowledge that objectivity in news reporting is very trivial. Language, of course, is not value-free. For example, Shoemaker and Rees identified 5 general factors that influence the formation of any media content. These 5 factors include individual factors such as writers' biases and educational and cultural background, media routines such as common rules of thumb in newsroom, organizational factors such as editorial policies, extra-media factors such as advertisers, and overall ideology such as propaganda and hegemony, all of which affect how journalists write, gatekeep, angle, and publish stories. Differing definitions of newsworthiness. The set of criteria used in evaluating the newsworthiness of a science issue are the same as that of other issues. Thus, most science news that is published in newspapers has some characteristics of novelty and human drama and focuses on consequences or impacts, especially in disaster risk reporting. Journalists are tempted to focus more on human interest topics where their audience can relate to, instead of popularizing a hard science topic that is usually viewed as bland and uninteresting. Scientists see this as an unnecessary move, leading to sensationalized science news. Differing time frames between media and scientific works. Scientists understand and value a long process of validating truths and knowledge claims, but journalists have unforgiving deadlines that require them to write, submit, and publish in a short period of time. This makes the journalists settle to formulaic news frames that do not require them to do in-depth research to explain a complex scientific concept. As Stoner 1997 suggests, science reports are most of the time treated as informative rather than explanatory, where the 5 W's and 1 H are used for evaluating correct news writing. However, even science reporters usually omit the why, because long explanations can eat a lot of limited space in newspapers and time in TV programs, require thorough research work that hinders them to beat the deadlines, and the question itself raises more questions than it can answer. It is also in this perspective that scientists criticize journalists for not doing their research assignments before conducting an interview, while journalists expect scientists to give them only what they need right here, right now, in order to simplify a seemingly complicated way of obtaining relevant information. These sources of tension are only one among other things that shape the framing of science-related social news, such as disaster risk reporting. But how are science news here, including disaster risks, are framed in the media? In a semantic network analysis study by Dimaano in 2013 about the reporting on several typhoons to hit the Philippines, she reinforced the belief that typhoon reporting, at least in the Philippines, is usually divided in 3 phases. In the first phase, which she called the preparation frame, news media are flooded by news stories that focus on typhoon's characteristics and direction, government plans and activities, and every information that potential victims can use for survival. This frame has dominantly an alarmist stance, or tone, working under the premise that the media has a social responsibility to help people prepare for the disaster. During and immediately after the typhoon, The effects frame starts to flood the news media as reports on immediate impacts are given a lot of space and airtime. Here, reports about the number of casualties, impacts in the economy, general well-being of the victims, as well as local government's efforts in providing immediate reliefs dominate in the news stories. This frame has dominantly an informative stance, working on the premise of the basic objective and function of media, to inform the public about what is happening from the ground. Then, news stories begin to shift from effects to recovery, where an analysis of what went wrong or right dominates the news. Specific topics such as updates on sending of relief goods, rebuilding houses, and receipt of foreign aids, as well as human interest stories about survival and moving on, are seen in the news narratives. But most importantly, this phase is characterized by the media scrutinizing the politics in recovery, which most of the time leads to finger-pointing and fault-finding by questioning the effectiveness of the government in responding to the needs of those affected. The tone of reporting becomes more critical and conflict-oriented as the media now shifts its implicit function from being objective informers to being fearless watchdogs. Our recent experiences with Typhoon Yolanda tell us the different ways on how all the actors reacted and how the news was handled. As expected, several news stories have focused on alarming the public about the extent of devastation and the actual reporting of its impacts from the ground. News media as a whole was commendable by informing the public about such relevant information to the extent of risking their lives just to keep the public posted about any development. Some news stories also feature reporters on the ground who drop their cameras and actually help victims to survive and cope. However, it is of particular importance or particular interest to look at stories that use conflict frames, showing how scientists, government, the media, and the public blame each other. When reflections commenced by asking why the mess happened, the public was quick to blame the media for failing on its responsibility to provide information just in time. The government points to the media for focusing too much about the negatives. Scientists point to the media for inadequate reporting about the science of disaster and its risks. The media, in turn, blame both the scientists and government. Much of them imply a certain level of incompetency on their parts. Carrying along this discourse of conflict, a considerable attention was even unbelievably given to the drama involving the verbal tussle between two well-known newscasters. Giving much space and airtime for reporting such conflicts were seen as counterproductive as it removes the focus to the more important things that the public should know and care about. What the experiences did something positive, however, is the bringing to the fore the importance of communicating science and risks. It can be surmised that the media did not actually lack efforts in communicating about the incoming disaster, as reports were included in routine weather news segments as soon as the typhoon entered the Philippine area of responsibility. In a survey done by SWS in 2014, right after Typhoon Yolanda, 45% of the Filipinos claimed to have received warning about Yolanda 1 to 2 days before, and 24% received the warning 3 to 4 days before. Interestingly, 23% of the respondents from Visayas claimed to have received the warning 7 days before, 39% received 3 days before, and 25% 1 to 2 days before. So just before Yolanda struck, 98% of Visayans had been already warned. What lacked, however, may not be the quantity of reported news stories, but the depth of the news content and the saliency that the media put to the news item. Stories to alarm the public about the incoming typhoon have to compete for newsworthiness with news bearing the dominant political issues at that time, which include the coverage of barangay elections, the President defending the disbursement acceleration program, and Mrs. Napoles attending a Senate hearing for the first time. Also, the after-typhoon reflections pointed out that very few, if none, framed news stories to explain not only the science behind typhoons and cyclones, but the translation of risks from technical knowledge to something more digestible and practical to the non-scientist publics. Referring from the same SWS survey, despite receiving warnings way before the typhoon, and despite 89% of the victims in the Visayas claimed to be aware of typhoon bulletins released by Pag-asa, 22% of people from Region 8, where Leyte and Samar belong, still claim to have underestimated the strength of the typhoon. An excellent post-disaster reporting analysis by the Center for Media Freedom and Responsibility in 2013 claimed that the term storm surge was not explained by the media before the typhoon, despite the government and scientists already providing an infographic about it. Again, the issue of differing definitions of newsworthiness comes in. Adding depth, therefore, at least means that science news discussing risks should go beyond the more conventional straightforward reporting and focus on the whys and what to do's instead. The aim is not only to inform, but also to make people understand the risk, provide cognitive connections between technical knowledge and their everyday experiences, and provide them a basis to believe why they should act according to what they understood. The question, of course, is, can the media able to do that? The answer is yes, provided that several adjustments are done regarding the relationship between scientists and journalists and the news culture where journalists function and operate. This section argued that the idea of science usually getting bad publicity and the media receiving blame for public's ignorance came from the disparity between the two cultures, including the professional values. Science news frames are shaped by subjective influences that reflect the disconnection between scientists and the media. When the public turns to the media for information, the evident implications of this cultural and professional dissimilarity usually resulted to the misinformed public. The next section discusses the concept of science communication and risk communication. Clarifying these concepts converge where they converge and diverge, as well as analyzing the implications of such activities can shed light about the roles of mass media in disaster risk reporting. One of the most common misconceptions about science communication is that its function only includes simplifying the scientific jargons in order for the non-scientists to understand them. Although most science communication initiatives in the past are dominated by such activities, the discipline is much more complex as it goes beyond the premises of public science literacy. It also caters the information needs not only of the non-scientist masses, but also of the policymakers, technical workers, and even scientists themselves, and all others, depending on to whom the term public is referred to. What further complicates the process is the acknowledgement that science communication is never an objective enterprise, as its content, a science, process, and communication, and its products, like communication materials, are not value-free. This led to different ways on how science is, may, and should be communicated. Broussard and Lewinstein in 2010 identified two general categories of how science communication initiatives are done. One privileges information delivery, and the other one privileges public participation. Out of the two general themes came the four conceptual models of public understanding of science. The following are the discussions of each model. The first is the deficit model. This model assumes a public that is nearly ignorant about science and almost incompetent to understand complex science issues. The deficit in knowledge, the scientists assume, should be filled in by genuine scientific information from the scientists, hoping that the knowledge gap will be addressed and the society as a whole will become scientifically literate. Following the assumption that communication is a tool to influence others, common science communication initiatives using this model include literacy surveys, persuasive communication strategies, and entertainment education. Popularization, which had become almost always synonymous to science communication, was born out from this model. This linear top-down perspective of science communication asks science communicators to be facilitators who should design instructional communication strategies to reach as many people as possible, mostly using mass media. The next model is what we call contextual model, and this model assumes a relatively active public who is able to understand complex science information given a particular context. The deficit model was criticized for its one-size-fits-all strategy, which is most of the time ineffective in achieving its objectives. The contextual model, on the other hand, acknowledges that people process information according to social and psychological schemas that have been shaped by their previous experiences, cultural context, and personal circumstances. As an implication, science communicators are asked to know their audiences very well before communicating science topics by targeting a specific audience segment that would require them to present the same scientific information in different ways. In-depth needs analysis are usually done in order to tailor-fit the messages to a particular audience segment. Thus, unlike the deficit model that strategizes communication activity From the point of view of a non-communicator scientist, specific science topics communicated to a specific audience avoids the tendency of science to be too trivial for practical applications. The model then shifts from a stimulus-response cause-effect communication perspective to value more the aspects of the functioning of the different parts of a communication system, such as context, sources, messages, channels, and receivers that might lead to action. The next model is what we call the lay expertise model, whereas both the deficit and contextual models explore the ways on how science can be effectively disseminated to the public. Lay expertise explores the way on how to make the public engage in science activities. This model assumes a very active public with an assumption that the public possesses scientific knowledge, practices that have been adequately tested through time. Indigenous knowledge, for example, can be scientific in its own right. This model follows the critical paradigm that not only challenges the legitimacy of the Western science, but the position of science and scientists in the society. It argues that the so-called scientists from a Western perspective can learn from the non-scientist public. Thus, science communicators who subscribe to this perspective lobby and facilitate the bottom-up communication approach to privilege local over Western knowledge. The last model is what we call the public engagement model, and this model follows the participatory and pragmatic approach to communication, and thus focuses on the democratization of scientific knowledge. Of course, this model assumes an active public, although the assumption is they already know the scientific topic before they can engage in a meaningful dialogue. Science communicators using this model in communicating science act as facilitators of the dialogue, where every stakeholder that has a say in a scientific concern is invited to meet together, negotiate their demands, and work together despite their differences. Public participation then is emphasized by holding public fora to address issues of incommensurability. At this point, it is necessary to clarify that risk communication is just a subset of science communication, and they are not always synonymous. Whereas the content of science communication talks about science in general, talking about risks is highly contextual and requires specific audiences. Thus, what makes risk communication different from science communication in general is the saliency of the risk that both the public and the media place. Science communication methods will feed the background information about the hazards, while risk communication will make the potential victims to understand and act according to what they understood. Also, trust and credibility are important in communicating risks. Popularizing science topics can be interpreted by most as trivial, but because of the saliency that the public attaches to the risk, the trust that they have both to the communicators and the sources of information, that is, the scientists, and the level of credibility they attach to both actors play a major role in making the public act according to the risk being communicated. Most risk communication efforts are done using the deficit and contextual model, especially during crisis communication. However, a more specific type of risk communication, known in the literature as consensus communication, follows the public engagement model. Interestingly, several reports after the Yolanda disaster did not mention any attempt to engage the potential victims in communicating the possible risks using participatory approaches. So having this in mind, let us now analyze the roles of mass media in communicating science and risks and the adjustments that they can do in order to improve disaster risk reporting in the country. Media practitioners reporting the science of disasters and risks usually follow the deficit model because of the limitations of both the medium being used and the nature of their profession. Whereas the contextual model encourages communicating science and risks in a highly contextual manner, mass media such as TV and radio are designed to disseminate information for large-scale audiences. Typhoon warnings during the preparation phase can be adequately disseminated using this media, and science journalism in the country is effective in that aspect. However, explaining to a segmented audience the risk that they shall be facing before the disaster may require some communication methods that are more personal, such as holding a public forum or dialogue in a barangay hall, or issuing alarms and warnings using the local media. In this way, the communicators are more familiar with their audiences, enabling them to tailor fit messages according to the characteristics of the audiences whom they are conversing with. This brings us to the next concern, which is actually a question of delineation of professional responsibilities. If communicating risks is highly contextual and thus requires communicators to be on the ground, Is this level of risk communication still within the scope of the responsibility of the journalists? Journalists are trained to have an eye to report on what is happening, and very seldom to facilitate community organizing efforts that most risk communication initiatives necessitate. Nevertheless, media practitioners are very instrumental in explaining the disaster and its potential risks before the disaster happens, and their efforts to laymanize technical jargons for weather forecasters is the first step for the public, especially the potential victims, to understand the risk. The next concern is the accuracy of popularization activities. It is very tempting for a media practitioner to simplify the content rather than the language. This tendency has a lot of impact in risk communication, as pertinent details about the nature of disaster and risks might inadvertently be deleted, depriving the public to have an informed decision on why and how to appropriately act. But the bigger question is, are the media practitioners equipped to digest complex science principles and laymanize them in an accurate manner? Well, most of our media practitioners may have limited encounters with science and scientists, and limited trainings in science reporting per se. Many news agencies rotate their reporters in different beats. Thus, many reporters may not have an opportunity to specialize in everyday science topics such as weather forecasting, environment, and health, unless the journalist is a freelance science writer. Many students in communication do not have adequate units in technical science subjects because of their course's curriculum. Even scientists do not have adequate trainings in communication, making them reserved and sometimes detached from media practitioners. To further our point, most media practitioners had been acquainted faintly about scientific culture during their schooling, but most scientists had never been acquainted in media culture even after they finished their degrees. The effect of this disconnect, as discussed, is revealing in the same SWS survey quoted earlier. 70% of the respondents agree that typhoon warnings being issued by Pag-asa are too long. 62% said they have too many technical jargons. And 55% said typhoon warnings have too many numbers that have no meaning to oneself. The key to eliminate this problem might be to train potential journalists to work in a specific science discipline and train the scientists on how to deal with media practitioners. Another way to keep accuracy in reporting science and risk is to hire a scientist or a technical expert as part of the production team to serve as a science consultant. Kirby reported that movie production houses in Hollywood usually have resident technical experts when shooting movies, mostly if the story is classified as sci-fi. In this way, the scientist is greatly involved in the news writing process, where he or she can provide immediate feedback to the journalist or negotiate the contents with the editors right here, right now. Media practitioners can also communicate using science, using the lay expertise model, by producing special reports in news programs and or segments in magazine programs that highlight indigenous science practices. The challenge, however, is to how these types of programs can get adequate airtime, as conventional knowledge says that commercial media producers are reluctant in giving much airtime for science topics, as it does not usually sell. But if science topics are presented to highlight its practical applicability instead of being too entertaining, too trivial, and too magical, the audiences might appreciate it. However, empirical evidences are yet to be produced in order to back up these claims. What the media practitioners may find it more challenging to do is to use the public engagement model to communicate risks. Awareness to a risk, which can be addressed by the deficit model, does not necessarily guarantee action. But literature found out that consensus-building type of risk communication activities are effective, especially when the risks are not yet fully understood. The public always expects that they should be included in the process, as they usually see this as one of their basic rights, and a proactive stance for them to have a sense of personal importance and collective ownership. This type of risk communication is advantageous for both the communicator and the public, as trust is formed along the process. But then again, do we expect media practitioners to do that for us? Is this still a responsibility of journalists? If yes, either are they ready for the task? Unless the whole media culture is willing to make drastic and necessary changes to address these issues, then we may see journalists ably extending their current roles and responsibility to be catalysts of change. But for now, it seems to us that the best media can do is to accurately translate scientific concepts into something easier to understand and apply. Make sense of the risks and report them to specific audiences. Work closely with scientists and harness their social networks to mobilize people all during the preparation phase, because they might be busier in reporting the immediate effects right after the disaster and in analyzing what went right or wrong during the recovery phase. This section explored the role of mass media in communicating science and risk after a basic discussion about the nature of science and risk communication was presented. We clarified that science communication is usually done in 4 ways, corresponding to the 4 models of public understanding of science. Each model targets specific objectives and is guided by different epistemological assumptions that should guide science communicators in communicating science. It was also discussed the difference between risk and science communication, with the former usually requiring more effort on the part of the communicator. The responsibilities of mass media were teased in order to highlight what the media can still help in science reporting in the country. So, where do we go from here? The holding of this public lecture to bring us together, to bring different minds to make sense of our experiences, is a proof that exciting changes and adjustments will be happening in the future. For example, the public did not ever lose their trust to Pag-asa, as the SWS survey revealed that 67% of Filipinos strongly believe in typhoon warnings they release, with 70% of the victims and 72% of the non-victims from the Visayas also claiming the same. Credibility is there. Only the translation of jargons into something more understandable is what the public is asking. Are scientists willing to be trained to understand the media culture? Are the media practitioners willing to be trained to understand the science culture? In fairness, scientists have become more visible now in the media to explain disasters and risks, mostly as guest experts in news and current affairs program. This is a good way to maintain the smooth relationship of scientists and the media. However, it is hoped that media should allocate more airtime and space to talk about the science of disasters and its risks, even when no imminent disaster is coming. As seen in the earlier discussion, mass media can greatly help in communicating science and risks right before the disaster. Will there ever be enough saliency and depth to disaster news reports in the future? Are the media willing to design news reports that are more relevant to an identified specific audience? How much of the airtime are the commercial networks willing to spend for devoting an hour of regular discussions about science, disaster, and risk reduction? Risk communication, as argued, is best communicated into a segmented audience where a thorough needs analysis was done before actually commencing to communicate. In this way, the messages will become more relevant to them, with the hope that they act according to what they understood. Are media practitioners willing to do such initiatives that might already be outside their usual job description to fulfill their ethical duty and social responsibility to help the public access significant information for their survival? How would media practitioners go beyond the traditional function of reporting to be a support system for disaster risk reduction and management? Interestingly, some media outfits have initiated the hiring of resident experts who understand the ins and outs of the news culture. At least the major TV networks have executed praiseworthy initiatives that go beyond informing the public about disasters. As scientists and media continue to work together, what could be the future implications of their relationship becoming more and more complex? To what extent should the scientists be involved in shaping news stories? And to what extent should journalists be allowed to popularize and put some human drama to an already dramatic science topic? It is very difficult also not to acknowledge here the role of netizens in disaster risk reporting. The rise of social media enabled the public to inform, act, and mobilize people in times of disaster. They have a very vital role to do when disasters strike. Even science and government institutions have utilized the power of social media in times of disaster. So is this an indication that the public is becoming more and more informed and interested in science, particularly disaster risk mitigation? How can scientists more effectively harness these tools? Is the public now taking the driver's seat in reporting disasters? How can media practitioners use these tools to communicate their science causes, aside from using them as an avenue for citizen reporting, an alternative medium to gather data from the site, and or mobilize citizens to act? How can the media and public further their unified causes of informing everybody about disasters and risks? We have already learned our lessons when it comes to how scientists, the media, and the public behave before, during, and after disasters. It enabled us to meditate on our own roles, the reflections of which hopefully translate to actual practice. Disasters will inevitably get more disastrous, so scientists and media practitioners will still have a lot of opportunities for fruitful collaboration and respectful partnership. In the advent of climate change, science and risk communication will become more and more important, and thus both the scientists and the media should make their own adjustments in their roles to educate the public, whoever the public may be. Thank you very much. As I end this presentation, let me address some of the key questions provided to us by the Third World Center Studies, which had already been answered somewhere in the presentation, and I'm reiterating this just for clarification purposes. First question is, what is science communication? The answer is, science communication is a broad term for a field that focuses on any science and science-related topic as the content of any communication activity. It is usually related to popularization or laymanizing scientific jargons, but as discussed, it goes beyond that. In DevCom, we define science communication as communication of the product, content, processes of science to various publics with the purpose of promoting development. The public includes scientists, technical workers, policymakers, and the general public. Second question, what is the role of mass media in the intrinsic relationship of science communication in natural disasters? First, their role is to work closely with scientists. Second, they should translate scientific concepts into something easier to understand and apply, balancing the accuracy and artistry in news writing. Third, to make sense of the risks and report them to specific audiences. And fourth, to harness the social networks to mobilize people before the disaster happens. Question, how does the mass media situate itself as an active player in science communication and in reporting climate change in particular? Answer, usually mass media functions as alarmists in a good way, informer, and watchdog. The challenge for them is how to communicate science by discussing the whys and communicate risks by discussing the what-to-dos. What is the current state of science journalism in the Philippines? I have no empirical data as of now to conclude where is science journalism now in the Philippines, but a quick Google search of science news articles regarding disaster brings a lot of hits, which means quantity of news stories regarding this might not be a problem. What is lacking is the depth and saliency of these news stories to make it more relevant to a specific audience. There is a growing number of reporters who are writing science news, though, and this is an exciting event to look forward to. Is there a reluctance that science reporting will not sell to the public? Again, I have no empirical data to conclude that this is either true or not, but several literatures from other countries claim that commercial media do believe that science usually does not sell. But personally, I think if science will be packaged in such a way that its content will become more relevant to the audience and broadcasted in the right time, targeting the right audiences, well, science programs might sell. How can we describe the relations and dynamics of science communication among scientists, journalists, and the public in the Philippines? In the past, there is a glaring gap between scientists and journalists, the gap of which existed because of the claimed disconnected culture of science and arts and the similarity in professional values. But due to our recent experiences about disasters, all of these actors are now trying to work together harmoniously for the common good. Special attention is of course given to scientists and journalists, as most of the time, their cultural and professional differences are believed to be the causes of the misinformed public. So how should effective science communication be conceptualized? This is a type of communication where the audiences are seriously taken into account, whoever that audience might be, including scientists. Is it about increased awareness about the issue? That might be the first step, but being aware about something does not translate into action, or at least intention to act. Question, or it should also aim for public engagement in disaster risk reduction and management? The answer is communicating risk should be participatory in nature because messages should be tailor-fitted to an audience within a context. Participatory approaches such as consensus communication is a better option to communicate risk. The question now is if the media are willing and ready to accept this role. What ethical aspects should be considered by a science journalist? Many, but the key is to balance the ethics of science and the ethics of news writing. Is there such a thing as Filipino science communication, or do we just adopt international standards? How do we factor in cultural context and specificities? We have yet to clarify our own definition and conception of science in a cultural perspective in order for us to discuss if there should exist a Filipino psychom. For now, we are using international standards mainly because we have a big gap in research about local science communication initiatives. So what is the future of climate change? This is the last question. What is the future of climate change risk reporting in the Philippines? Very bright, very bright. But we still had a lot of things to do to achieve that brightness. Thank you again.